Hi, I'm Madhu Datla. I'm a senior engineering manager at Intel, responsible for developing DevOps and systems engineering capabilities.
Hi, my name is Peter Tiegs. I'm a principal engineer at Intel, focusing on DevOps, and today we're going to talk a little bit about our journey supercharging software development at Intel. Madhu?
Intel processors and products are used everywhere, like laptops, mobile devices, servers, autonomous vehicles, and IoT devices. Within our client organization, in the last 5 to 6 years, the number of products that we have been delivering has grown exponentially year over year. Because each of our customers wanted to differentiate their products, we created a segmentation strategy, which allowed us to meet growing market demand and supporting a large number of use cases. In each of this product SKU can be a different set of components interacting with your processor. And the software on that product would differentiate how the system would behave in different situations. For example, I have an Ultrabook here, which can be in a laptop mode, or a tablet mode, or a tent mode. And in each of these modes, the user experience is different, and the software and hardware interactions are different. Another customer may want to just sell a thin and sleek laptop at a different price point. There are several thousands of products from our partners like Google, HP, ASUS, Lenovo, Microsoft, each of them offering different price points and different usages. So essentially, the number of products have basically exploded. Every year, we are integrating 4x more products. And this is happening across multiple operating systems like Windows, Linux, Chrome, which are getting more frequently released. So our ecosystem has become extremely complex and dynamic, and our hardware had to be validated and released faster with the highest quality of standards possible. In order to provide the best customer experiences on these Intel systems, and our development team is working across the globe. We have 15,000 engineers doing software development in a variety of languages and in multiple geographies around the clock. And one thing that is unique about Intel is our product development is extremely complex. One of the reasons is because we have a large dependency on our hardware, and in the early phases of our product development, the hardware is very, very unstable. Integrating 30+ software components on a daily basis, and that too that is getting developed across the globe, is not a trivial task. We had to innovate. We had to come up with enterprise-wide DevOps infrastructure to support the complex development here at Intel.
So as Madhu was saying, there's 30+ different software components that go into our platform level products, or the various SKUs that we have. This platform level continuous delivery mechanism that we've put together is based on common continuous integration and continuous delivery practices, but scaled up and set into a segmented strategy where each of these various software teams, whether it's the graphics driver, the wireless WAN driver, or the audio driver, runs their own CI process and then delivers those in a CI-like process into platform integration, where we bring in not only all of those software stacks, but the OS and the standard software and the drivers. Historically, before we started to look at this as a platform level continuous deployment process, we used to do big bang integration, where each of these teams would deliver their software at some arbitrary time. The system integrators would pull together, ask people for what versions, what share drive that version was on, what SharePoint site this version was on, and pull them all together, put them together once for the first time and see if they would work. And 9 times out of 10, they did not work, right? So what we did was we put together this process based on continuous integration, where we would incrementally add a new version against a baseline of all of these ingredients, assemble it into what we call a base SoC kit, and then turn on or enable different features depending on our target customers, whether it was for IoT or for client. As Madhu pointed out, we had a couple different client SKUs and capabilities, or even now going into the data center and server based platforms so that we could deliver a BKC or a best known configuration out to our customers. All of our software for platforms goes through this pipeline now, and we've enabled the common repository for sharing source code because of the ability to debug use cases by our upstream validation teams through source. And as you can imagine, with a diversity of software teams delivering into this system, as well as the system itself, we have a diversity of tools within our entire DevOps portfolio. I'm sure you recognize many of these tools operating in many of the different roles that we need in a complex DevOps system. And while it may seem like the right goal is to drive down to a single pipeline and a single set of tools in a single tool chain, we have found that that's not really an achievable goal in the reality of DevOps at a complex enterprise level system. One, software teams have legacy that they need to support, and there are certain things that may be tied to specific tools. Two, some of those software teams are coming in from acquisitions, whether we're purchasing a new company or a team is coming in and using that stuff historically, and they're not necessarily using the same tools that we've used historically. And one other really important piece is that we want to stay up to date and modern. As tools change and evolve, the DevOps space is incredibly dynamic now. And so having the ability to have a mix of tools in the system so that we can stay up to date with tools. We also need to balance both commercial